Okay guys, this is problem number 4, the first one when we're asked to actually graph, which is the title of the section. We're learning how to graph these things. And we're just going to follow the steps given on the first page. The first page where it says how to graph a polynomial. First is find the real zeros. So in other words, just find the zeros. Now, we've done a bunch of work finding zeros, right? The easiest way is if I can see right away if there's a way to factor it. And in this case, this is really easily factorable. If I see there's an x squared in common, right? So x cubed minus 2x squared, I can write that as x squared times x minus 2. Yeah, and already I've factored, I can see the zeros clearly. It's going to be 0 or 2. Those are my zeros. So let's in fact write that out. Zeros are, well, let's write it on the top right corner like we usually do. Zeros are 0 with multiplicity 2 and 2 with multiplicity 1. Or if it's multiplicity 1, I'm not going to say anything. I'm just going to write it out. So I have basically 3 zeros, two zeros where there's 0 and 1 0 when it's 2. Yeah, the 0 is 0 with multiplicity 2 and 2 with multiplicity 1. Okay, that was the first step. Second step was to consider the multiplicities. Okay, multiplicities. So this has multiplicity 2. That means when you look at a graph, if a graph has a multiplicity, if a 0 has multiplicity 2, what it means is it's going to just, wherever that 0 occurs, it's going to just kiss the graph and turn around. So it's either this picture, or it could be in the other direction from the bottom. You're going to kiss the graph right at that 0. So the 0 here is a 0, right? The example here we're thinking about is, think about y is equal to x squared. Y equal to x squared, that has a 0 of multiplicity 2, right? 2 because the power is 2. That 0 occurs right in the center. And if you think about the graph, it just kisses it and comes back up, right? It just touches and returns back to where it came. Now the example for something that has an odd multiplicity, so think about x to the third power. What does that graph look like? We've seen this before. It looks like this instead, right? So anytime you have an odd power, what happens is it goes straight through that 0. Again, the 0 is 0, but it has multiplicity 3 this time. So instead of kissing and coming back, it's going to pass right through that point. It could have also passed, like if this was negative, then it would have passed from the positive to the negative. So it could have also come from this direction on the top and then headed down towards the bottom as it passes through. Okay, well, now come back to our question. That's just sort of an example. In our question, we have zeros, multiplicity 0. I'm sorry, the 0 is 0 with multiplicity 2. And the other 0 is 2. So what I'm going to do is I'm going to plot those points. Here's the first one, 0. Here's the second one. Okay, what I know is it's going to kiss this graph, so it could look like this. And then it should pass straight through this 0. Or it could kiss the other way, come up from this way, and then pass straight through like that. So I have one of those two options, right? Okay, now is when we skip to the next step. Step number 3, consider the limits. So this is what we set the groundwork for in those first 3 questions. We want the limit as x approaches negative infinity. That's as it goes far out to the left, what's going to happen of our function. And what's the limit as x approaches positive infinity of our function. Okay, let's do the negative first. So if I put a negative, again, when we're doing these limits, I don't care about what the terms are other than the very first term, right? I'm only focused on this highest power term, x cubed. So what happens as x approaches negative infinity to x cubed? Well, it's negative, because negative times a negative times a negative is negative, and it's getting really big, so that's going to approach negative infinity. Okay, what about the other one? As x gets positive, then it's going to be x cubed positive, that's going to approach positive infinity. Okay, sweet. So now we just have to calculate one value between each interval. Okay, to be honest with you though, I think this is not really super necessary. I think you can figure it out without doing that. But if it's going to throw you off, then it's okay to calculate. I think calculating might be easier for you, so I'll do that as soon as I show you how to do it without calculating. Okay, so without calculating, if I look at this function, right, it's going towards negative infinity to the left, so that means it's getting lower and lower as I go left. So something like this. going that direction, lower and lower as x gets negative infinity. Then it's going to hit this 0. It's going to just kiss it because that's 0 multiplicity 2, remember? It's going to kiss it, and then it should come back up to pass straight through that 0 and head towards positive infinity. Yeah, so the graph should look something like that. Now, just to confirm that I was correct, then we'll come back to step number 4, and let's just calculate one value at each interval. That means one value to the left of the 0, one value between the two zeros, and one value to the right of the zeros. So let's just pick easy values to work with. 1 to the left, I think negative 1 looks like the easiest. 1 in between looks like 1 is the easiest. And then this is 2 here, so 3 would be the next one for that value. Alright, if I plug in negative 1, that's going to be negative 1 times negative 1 times negative 1. That's negative 1 minus 2 times 1. That's going to be negative 3. So negative 3. Yeah, if I wanted to, I could plot that point. Oh, down here actually. So the thing would have been steeper, a little steeper than I had originally graphed. Okay, now I'll put in 1. If I put in 1, that's 1 minus 2, which is negative 1. So over here, that means the thing actually looks more like this here, negative 1. So what I originally had was more of a rough sketch, but still the shape is pretty much the same. Okay, if I put in a 3, that's going to be 3 times 3 times 3, which is 27, minus 2 times 9, 18. That gives me 9, positive 9. So at 3, I'm at positive 9. So actually probably even steeper than I had drawn originally. And it's up here somewhere. So like that. Okay. Now does that match what I intended it to match? Does it go towards negative infinity to the left? Yes. Towards positive infinity to the right? Yes. Kisses the 0 with multiplicity 2, passes through the 0 with multiplicity 1. So that's the check. Alright, everything looks good. That's it.